The aim of this procedure is to determine the influence of chemical compounds on the storage and the voiding functions of the bladder. This is accomplished by first implanting a catheter in the bladder. After a brief recovery period, a control solution is infused via the catheter for 30 minutes, as intravesical pressure and voided volume are recorded. Over another 30 minutes, the animal is infused with a compound of interest. Ultimately, results can show how irritant chemicals alter the voiding pattern through the analyses of the voiding frequency.
The main advantage of this technique over existing methods, like the recording of the contractility of the isolated bladder, is that the function of this organ can be studied in more physiological conditions. For instance, the regulatory actions of the central nervous system are preserved.
Visual demonstration of this method is critical, as the surgery steps are difficult to learn, because there's a number of technical details and maneuvers that should be observed to ensure the success of the experiment.
To prepare the tube you want to implant in the bladder, first cut a PE50 tube at the desired length and put a small white piece of 18-gauge catheter over the main catheter. Then, create a small cuff at the end by flaming one end of the tube and flush it with saline to void any air. Now, induce anesthesia in a 10 to 12-week-old female rat with isoflurane. After inducing anesthesia, set the maintenance level of isoflurane. Position the animal on its back and place a small anesthesia mask made from a 10 cc syringe. After shaving the abdomen and disinfecting the dermis, proceed with the surgery. The following surgery is performed on both rats and mice in the same manner. Begin by performing a lower midline laparotomy to expose the bladder. Next begins the most critical portion of the surgery. Under a surgical microscope, place a purse string suture in the bladder dome using non-absorbable monofilament 6-0 suture. Next, using a needle, perform a small cystostomy inside the purse string. Insert the cuffed PE50 catheter through this hole. Thinner catheter tubes, like PE10, can have a higher and more variable resistance, so they are not recommended. Secure the purse string around the tube using a surgeon's knot. Then, gently pull the catheter outwards until the cuffed tip is directly under the suture. The piece of 18-gauge catheter is pushed towards the suture to prevent leaking. Check for leaks between the catheter and bladder with a gentle infusion of saline. Tighten up any leaks with additional sutures. Now close the abdominal muscles using monofilament sutures, leaving a passage for the catheter in the upper part of the incision. Tunnel the catheter into the interscapular region using a hollow metal rod, thereby preventing the animals from biting the tube after the surgery. The metal rod should be placed under the skin and above the abdominal and dorsal muscles. Push the rod through the animal subcutaneously to the interscapular region. Complete the surgery by closing the abdominal muscles and the skin with non-absorbable monofilament sutures. It is now very important to check the permeability and stability of the implanted catheter by flushing it with saline. The infusion solution should exit the bladder via the urethra. After delivering analgesics subcutaneously, close the external end of the catheter with a plastic film and anchor the catheter to the skin of the lower back of the rat. Finally, allow the animal to recover for 30 minutes. Before starting the cystometry, ensure that the instruments have been properly calibrated. Place the rat in a metabolic cage above a receptacle containing oil that rests on a digital balance. The next step is to connect the implanted catheter to a 3-way tap via a Luer stub. The tap should be connected to the pressure transducer and an infusion pump. The pressure transducer is further connected via an amplifier to the data acquisition system and a computer, which utilizes publicly available software. Begin the control measurements by starting the infusion pump to instill saline into the bladder over a 30-minute period. The metabolic cage is suspended over a digital balance, which is used to estimate the rat's voided volume. The intravesicular pressure is recorded as the bladder fills and empties. In the next step, drugs can be administered systemically or intravesically over another 30 minutes of data collection. When the experiment is complete, the animal should be sacrificed. A typical pressure trace from a rat shows that during fluid infusion, there is a slow pressure build-up in the bladder until a certain threshold is reached. Then, the bladder will contract and the urinary sphincter will open, allowing the passage of the instilled solution through the urethra. As such, the bladder is emptied, the contraction will stop, and the pressure will drop again to the basal level. Data collected from a mouse has all of the same features. Cystometry was used to identify the molecular targets of mustard oil, or MO. MO is a highly reactive compound that has long been used in experimental models of inflammation and hyperalgesia of visceral organs, such as the urinary bladder. As expected, an intravesical infusion of 10 millimolar MO induced a strong decrease in the intercontractile interval in wild-type mice. Curiously, mice deficient of the MO receptor TRPA1 had a result similar to wild types under the same conditions. In contrast, MO induced a much weaker change in cystometric parameters in a TRPV1 knockout mouse than in wild-type mice. Double knockouts of both TRPA1 and TRPV1 were nearly unresponsive to the MO dose. The data suggests that TRPV1 may play a key role in visceral irritation induced by MO. The average instantaneous voiding frequency before and during intravesical infusion of MO supports these data. The average frequency is relative to a saline infusion.
While attempting this procedure, it's important to ensure that the catheter remains firmly attached to the bladder, so that there is no leakage of the infusing solution into the abdomen.
After watching this video, you should have a good understanding how to measure intravesical pressure, which entails the implantation of a catheter in the bladder and the placement of awake or anesthetized animals in the cystometry stage under controlled bladder perfusion.